Moving right along with Unit 6, our last unit of the school year. We have our final, of course, but this is the last regular unit. So let's get into it. 6.04 binomial distributions. What are they? What are our goals? We're going to find out right now. The goals are determine if a variable has a binomial distribution, interpret a binomial distribution, and create a binomial distribution table and a graph for a discrete random variable. So what is this? Well, binomial distribution is a type of probability distribution that models the number of successes in a fixed number of independent yes or no experiments, each with the same probability of success. In other words, binomial distribution applies when there are a fixed number of trials. We know number of trials as n. And what is a trial? It's a try, right? It's something happening. Each trial has only two outcomes, either success or failure. There's no other option. And the probability of success is constant for each trial. Here's an example. What is the probability of getting exactly 1/5 when you roll a die 2 times? Is there binomial distribution happening here? There is. They told us we're going to roll a die 2 times, so that is a fixed number of trials. They also told us they want to know the probability of getting exactly 1/5. That is what they want. So the success is rolling a 5, where a failure is everything else. There are no other possible outcomes. And finally, the probability of success is constant for each trial. Well, it is. Because how many sides are there on a die? 6, right? So probability, I'll just put of S for success is, well, there's only 1/5 on a 6-sided die, so 1/6, or the probability of failure is anything other than a 5, right? So any of the other 5 sides. And those probabilities will stay the same because we're dealing with the same die no matter how many times we roll it, in this case 2. Great, so that is a situation where you have binomial distribution. Let's test your skills on that, doing exactly what we just did, but for yourself. Question is there, read it. You have the 3 things you're checking for in the peach box, and then select all true statements. You should be looking here to see what they're saying. That's all the information you need, and then you're checking these 3 things. So first, let's read. When a die is rolled 3 times, that is a fixed number of trials. And remember, that's represented by n, right? So n is 3. What else? X is the number of 2s rolled. They're looking for 2s, right? So we're rolling a die. We want 2s. That, again, is a situation where there is only a success or a failure. None of the options here ask that. So we know the first 2 are checked off. And we've picked the only true statement so far that we can. And third, the probability of success is constant for each trial. Well, it is, right? How many sides of a die have a 2? 1. 1 out of 6. So that is the probability of success. That also tells us the probability of success is constant. And since all 3 of these are true, that also means that the variable x has binomial distribution. Now, we know how to find binomial distribution and see if it's going on. But what's that useful for? Finding probabilities, of course. These are the 3 steps you need to know to calculate probability with binomial distribution. write them down, have them in your notes. You will definitely need this, as well as these three things you need to check. But let's work on finding the probabilities by writing these down, and then we'll work through a problem one step at a time. And here we go. The question is, what is the probability of getting exactly 1 5 when you roll a die 2 times? Seems like a simple question, but there's actually a decent amount of work to do. Exactly 1 5 when you roll it 2 times. Well, first we need to make a tree diagram with each branch showing the probability and the outcome. Each branch shows both of those things. Go ahead and try to make your tree diagram now. And hopefully it looks something like this. Here I'm showing the first roll. The first roll has the probability and the outcome. The outcome of landing on a 5, that probability is 1/6. Or I could land on something other than a 5, that's the outcome, and the probability 5/6. So right here, that's my part of the tree for the first roll, but we're rolling the die 2 times, so we're going to do that again. No matter whether I landed on a 5 or something else, I still have the chance the second time to land on a 5 or something else. So you see those same outcomes and those same probabilities. And I would leave quite a bit of room when you're making these trees because you have lots of fractions close to each other. Great, we have our tree. Step 2, multiply the probabilities of each possible final outcome. Let me be specific. What we're talking about is rolling a 5 and then a 5, or a 5 and then something else, or something else and then a 5, or not a 5 either time. That's what we're talking about. Those are all the possible outcomes. Hopefully you got something like this. Not a 5 and not a 5. Well, you're multiplying those together, those two probabilities, 5/6, 5/6. You see that there. And so on, right? Not a 5 and then a 5, not a 5 and then a 5, 5/6 times 1/6. Boom. And you keep working these out, multiplying for every possible final outcome. And the last thing you need to do is multiply probabilities for the same outcome. Meaning, if you didn't roll a 5 at all, if you rolled a 5 once, or if you rolled a 5 twice. Because we're only rolling a die twice here, can't have more than 2 times. Did you get the answer? So remember, the outcomes we're looking for don't really depend on the order, right? We're talking about and looking for how many 5s do we get when we roll these die 2 times. Well, this situation and this situation both have a 5 being rolled once, and that's exactly what they want to know. So since those are the same outcome, we're going to add them together and simplify. There's our answer. There's a 5/18 chance of rolling a 5 once when you roll these die 2 times. Okay. What about a bar graph? Sometimes known as a histogram. Given the probability distribution below, assume there are 2 trials. Look at the table. We have probabilities here, number of successes. So this is 0 successes, 1 and 2. Okay, because there are 2 trials. So we don't really know what's going on here, right? But we do know there are successes and failures, right? 0 means failure. And they want to know the probability of success that matches this bar graph. If the answer comes to you too quickly and easily, I'm going to tell you in a moment the most common mistake. But give it a try first. Okay, the most common mistake is saying, oh, here's a success and here's two successes. So if I just add this probability and this probability, I have my answer, 0.32 plus 0.04, 0.36 done. It's not so simple. Read the question carefully. Here's my explanation. And a common question, common mistake as well. Why can't I just add the probability of 1 and 2 successes like I just did? Well, you can, but it depends on what you're trying to find. In this problem, remember the question was, what is the probability of success? That is the probability of successes on a single trial. 0.36, like I just said a moment ago, that is the probability of getting at least one success in two trials, which is different from the probability of success on a single trial. And we're not given much information, so we make a tree diagram that's pretty abstract. We're not putting values in. We're just making a tree diagram saying, okay, I could have a success or a failure. And we know the probability of success, we can write as P, and failure is everything else, so 1 minus P. Same thing, success, failure, because we have a second trial. Now, what do? We need to solve for one of these situations, either 0 successes, 1 or 2, to solve for P. Well, you could go through these and try different things, but I found the simplest solution to be to calculate the probability of 2 successes. And remember, when we calculate probabilities with a tree diagram, we are multiplying them together. So P times P, which is also P squared. And we do know the probability of 2 successes, don't we? They show us that in the table, 0.04. Set them equal, take the square root. Usually we use a plus and minus, but there is no such thing as a negative probability. So we're going to keep it all positive. Use your calculator there to give you 0.2, the probability of 1 success in these two trials is 0.2 or 20%. Let's try this problem before our exit ticket. I encourage you right now to practice this one for yourself. Okay, suppose the dial on the spinner is spun 2 times. Notice A, B, C, D, okay? X is the number of times the dial lands on either A, B, or C. Fill in the probability distribution table. Okay, is there binomial distribution happening? Well, they told you it's spun 2 times, fixed number of trials. They talk about landing on A, B, or C, so that means success. Only other option is land on D, which would be a failure then. And what's the third thing? Do you remember? Fixed number of trials, success or failure, probability of success or failure being the same every time, being constant, right? Well, there's 3 out of 4 parts of this diagram will always be A, B, and C, and 1 part will always be D. So yes, that is constant as well. So here's how we do it. Success, we can have a success or failure, right? And you could write A, B, C here and D there. Same thing, just simpler to write S and F. Success is 3 sections, A, B, C out of 4. Failure is 1 section, which is D, 1 out of 4. Now, there are 2 spins going on, so we do that again. Similar to what we've done before, right? Some good practice here. And they want us to not just answer one of these questions, they want us to fill in every possible option. So we look at our tree diagram to do that. Okay, we know there's going to be 0, 1, or 2 successes based on the table. 0, 1, or 2 listed there. And let's see. Success, success, that's 2 successes. So multiply those probabilities. There we go. Put it in your table. 1 success. Well, this is success then a failure. Failure then a success. So we multiply and add. So multiply these two and multiply those two and add them together. Give you 6/16 simplified to 3/8. And I noticed there's a mistake in the table. Let me just double check that the work here is accurate. 3/4 times 1/4. Okay. 3/16. 3/16. Yeah, 6/16. 3/8. Yes, that should be 3/8. And then 0 successive would be the fail. So 1/4 times 1/4. And then a question in addition, what's the probability that the dial lands on either A, B, or C only once? Well, that would be the 3/8. And our exit tickets. Try. See how you do. And the answer is C. When a coin is tossed 4 times, X is the number of tails. Determine whether the variable X has a binomial distribution. Select all of the true statements. Okay, a coin is tossed 4 times, X is the number of tails. So there's already a fixed number of trials tossed 4 times. We see that there. X is the number of tails. Since they're mentioning tails, that tells us they want tails. That would be a success. And if we're talking about a coin with 2 sides, that probability is 1/2 every time. And finally, we're going to say, yes, the variable X does have binomial distribution because also not only is tails determining that's a success or failure every time, but it's also going to be the same probability every time. That's it for now. See you next time.